was the power rule. Log base A of x to power b. We already used this a few minutes ago. We brought the power in front as a factor, not addition. I was going to say addition, I wrote addition. No, that's not the case. So a product, not addition. So b times log base A of x. Okay? I have to correct my mistake there. So this is b multiplied by log base A of x. And this is the power rule. There are other rules like log in any base of 1 will be 0. Log in any base of the base is 1. For example, common log of 10 is 1. Common log of 10 is 1. Natural log of e is 1. Okay. Finally, we get to the derivative of this function. So when we differentiate natural log x, we get 1 over x. Yes, of course, if I have a function, if I have natural log of a function prime, I would have 1 over the function times the function prime. Okay, so now please look at problems on page 319. The reason why I'm asking you to look and see, let me know if you want to work on any equations, anything that is from algebra before we differentiate. If you want to use the change of base formula, here's the change of base. I should mention that here as well. Why will I ever want to change the base? Most calculators don't allow you to. I don't know if this calculator does it. I was never curious to see. Because I know the formula, I can find anything. So I'm not sure. But for example, if I have log base 3 of 9, I don't need any calculator for this. Because it's a number. I know I can change this into an exponential equation. 3 raised to y equals 9. And I know that y must be 2. There is no discussion there. Only 3 squared will be 9. So then the answer here is 2. But if you ask me, find log base 15 of 3, I would not be able to, even if my life depended on it. You can say, but it's very easy. You do the same thing you just did. Yes, I know, but I will not be able to give you an answer. So I can still determine this because the change of base formula says if you want to determine, let me just work on this example now. If you want to determine log base 15 of 3, no problem. Either use natural log of the number over natural log of the previous base, both natural log, or both log, same thing of 3, over log 15. Because you have those. All calculators have natural log and common log. It must be only one number because 15 is raised to only one number to get 3. This number has to equal this number. So log 3 divided, do not reverse these, so natural log both or log both. So log base 3 over log of 3 over log 15, and natural log 3 divided by natural log 15, they have to give us the same answer. And you can say, show me that this is true, no problem. I will raise 15 power the previous answer. And I guarantee you the answer must be 33. Now, if you truncate the number, if you write 15 power 0.40568, you will not get exactly 3. You will be very close. So that's why I recalled the previous answer, so the calculator uses everything, no error. So this is the change of base. So please look at problems 1 through 56 on page 319. If you need any refresher on anything. If not, we'll move on to differentiating and to applications. Anyone? Do we need anything from there, or we go ahead and differentiate?
56.
56 it is. Good pick. 56 has e to 0.07t equals 2. And the question is asking us to solve for t. That's exactly what we just did before we even got to this section. Very good pick, thank you. So I apply natural log, and it has to be to both sides. Only natural log has the property of allowing us to bring the power in front as a factor. 0.07t, natural log e equals natural log 2. I'm happy because I know that this is 1. So then t equals this over 0.07. Yes, I will approximate it. Natural log 2 is 1 point something, I think, divided by 0.07. So 9.902. I'm not sure how many decimal digits they want. Anything else you would like to look at from there? Or we go to differentiating. Different functions with log.
Can you do?
Yes, which one?
Can you do 38?
Yes, 38 it is. 38, I see it. Excellent. And that is natural log of the square root of e to the 6th. Nice problem. Okay. So I know that this is a power. What power? 1/2. So I have different ways of addressing this. I can write this, or I can say the power is 1/2, I'm going to bring it in front. I can do this here as well. At the same time, I can bring 1/2 in front here or directly here. It's up to you. So if we go that route, I know that the square root is a power. I bring the power in front because the natural log allows me to. So this is natural log of e to the 6th. But now, a natural log allows, by the power rule, allows again 6 to go in front as a factor. But I have to multiply it by 1/2. So I will get 3, 6 times divided by 1/2, by 6 times 1/2, or 6 divided by 2, same thing. Natural log e, knowing now that this is 1, the answer is 3. Nice pick. Here I could have simplified, multiplying the powers and get 3 from the beginning and then just move 3 in front. There are many different ways for this problem. Very nice pick. I like that. Anything else? Yes?
So then would 41 be the same thing then?
41.
Like,
Yes, let's look at 41. It's a different, they're all somewhat different. So natural log of 4 divided by e. First, I will write that this is natural log 4 minus natural log e because this is the quotient rule. Log applied to a quotient. This is a constant. I cannot do anything to it, natural log 4. And this happens to be 1. So then the final answer is this. You can approximate it if you want to. So natural log 4 and minus 1, 0.3863, depending on how many decimals they want. Good, very good. Anything else? Okay, if you find anything else, I can always stop and go back and show what you need. Okay, moving on to differentiate. I'm looking at problems now 57 through 90. Before we pick, because you may pick something like this, natural log of the absolute value of x is also 1 over x prime. And you can say why. And let me show you why. So the absolute value of x has two possibilities, either x for x greater than or equal to 0, or the opposite of x if x is negative. So therefore, natural log of this has two options. Either natural log of x or natural log of negative x. For x greater than 0, I cannot plug in 0. That's not possible. And for x less than 0. So now when I differentiate this, I'm actually differentiating these two for different x values. So natural log of the absolute value of x equals 1 over x for x positive, 1 over negative x times the inner function prime for x less than 0. But when I multiply negative 1 by negative x, I get the same thing. So the result is 1 over x for any x except 0. So that's why when we differentiate, natural log of the absolute value of x is 1 over x. Of course, if it's a different function, then I have to multiply by the function prime. But if in case you choose from 57 to 90, if you choose a problem with absolute value, I want you to know what is happening here. Okay, I will choose, first, I would like to choose 75. And you choose the next. So we have a function now that is natural log of x squared over 4. Because I know the quotient rule, I will change this function into natural log of x squared minus natural log 4. Because I know the power rule, I will put 2 in front. So you know me, I always try to simplify the function before I do anything. So now when I differentiate, this is gone because it's 0, it's a constant. 2 is a factor in front, and I differentiate natural log and I get 1 over x. So the answer is 2 over x. Now, if we look at situations a little bit more complicated, like 80 or 82 or 84 or 86 or etc. We're going to look at as many as we can. Any questions? Please stop me, please. Stop me if you have questions. Okay, so I was saying 78 first. We have natural log of 3x squared, no, that's 77. 7x squared plus 5x plus 2. So we want to differentiate this. It's 1 over the function times the inner function prime, 14x plus 5. Yes, I will rewrite it compact on one fraction. 14x plus 5 over 7x squared plus 5x plus 2. Let's also look at 80. 80 is another function f of x, which is a natural log applied to a ratio. I would recommend, even for this one, changing in the natural log of x squared plus 5 minus natural log x before we differentiate. And then f prime of x will be natural log prime, 1 over the function, times the inner function prime, minus natural log x prime, 1 over x. And you don't have to do anything to it. This is good enough. Unless something else follows, and then it's a different story. Then we have to find the least common denominator, etc., but not in this case. Let's look at a product. Let's say 82. G of x equals e to 2x times natural log x. This is a product, and I have to use the product rule. Function 1, function 2.